Welcome to a journey into deep time, exploring the future of Earth across a 7 billion-year timeline. We face an extinction event more devastating than past catastrophes, but this decline will be caused by the very star that sustains us, the Sun. The Sun, a main sequence star, is constantly fusing hydrogen into helium. This process is a tug-of-war between gravity and the outward push of fusion energy. The Sun gets over 1% brighter every 100 million years, a subtle increase that will eventually shatter Earth's delicate climate balance. This video assumes a timeline based on natural processes only, removing humanity's capacity to geo-engineer or terraform. These projections, while uncertain over deep time, are based on known laws of planetary science, geology, and biochemistry. In 100 million years, plate tectonics reshape the planet. Africa collides with Europe, causing the Mediterranean Sea to vanish. This collision creates new mountain ranges and closes the Red Sea and Persian Gulf. Australia also joins Southeast Asia. At 250 million years, a new supercontinent, Pangea Proxima, forms as the Atlantic and Indian Oceans close. This massive change triggers ocean stagnation, leading to a marine mass extinction. The interior becomes a super-arid desert, forcing mammals toward the poles. Earth's natural thermostat, the carbonate-silicate cycle, regulates CO2. However, a brighter sun speeds up chemical weathering, pulling CO2 out of the atmosphere faster than volcanoes can replace it. This imbalance will eventually starve the biosphere of the carbon it needs to photosynthesize. At 500 million years, the sun is 5% brighter, accelerating weathering. CO2 levels crash below 150 parts per million. This triggers a, quote, plant-pocalypse, as C3 plants, including most modern vegetation, can no longer photosynthesize efficiently. About 95% of plant biomass dies off, collapsing the global food chain. Between 800 million and 1.2 billion years, C4 plants like grasses and corn survive on CO2 levels as low as 10 ppm, making a final stand. Eventually, even they succumb to carbon starvation, and atmospheric oxygen levels plummet to 1%. Animals starve and suffocate. The era of complex life is over. In 1 billion years, the sun is 10% brighter, and the oceans begin to boil. Surface temperatures average 50 degrees Celsius. The moist greenhouse effect causes oceans to evaporate faster than the water cycle can replenish them. Water vapor, a potent greenhouse gas, accelerates this evaporation. At 1.5 billion years, a runaway greenhouse effect turns Earth into a second Venus. The insulating blanket of steam raises temperatures uncontrollably. The oceans are lost entirely to space, and Earth becomes a planetary pressure cooker. Only transient puddles remain at the poles, briefly. Around 2 billion years, tectonic activity grinds to a halt. Without liquid water to lubricate plate tectonics, subduction stops. The crust dries out, leading to a carbon buildup. Volcanic CO2 remains trapped, creating a suffocating world, wrapped in a permanent blanket of CO2 and water vapor. At 2.8 billion years, the sun is 28% brighter, and surface temperatures reach 190 degrees Celsius. The last life on Earth, salt-loving microbes called extremophiles, hide in underground caves or the upper atmosphere. Eventually, the heat finds them too. Earth becomes a stagnant, lifeless rock with no biosignature. In 7.6 billion years, the sun runs out of hydrogen and swells into a red giant, expanding to 256 times its current size. As the sun loses mass, tidal forces pull Earth inward. The red giant sun consumes the inner solar system, engulfing and vaporizing Earth. After shedding its outer layers, the sun leaves behind a hot, dense core, a white dwarf. This remnant will cool over trillions of years. All memory of Earth, its oceans, forests, and civilizations, is eventually erased from the solar system. This is the natural timeline, assuming no human intervention. However, we are the variable. In millions of years, we could terraform Earth, move the planet's orbit, or colonize new worlds. The Earth story ends, but perhaps our destiny is to return to the stardust we came from.